Today, I would like to teach you how to find the zeros and give the multiplicity of each zero of the following function: x squared multiplied by 2x plus 3 raised to the fifth multiplied by x minus 4 squared. So the first step to find the zeros is we have to make sure that we have this in factored form, and we do. Basically, we're looking for something where we have like some a multiplied by some b multiplied then by some c, and then dot, okay? However many factors you might have. So this is in fully factored form. Now from here, what we can do is we set each of these factors equal to 0. Why do we do that? I got about 20 videos out there with specific examples. In every video, I explain in detail how that happens. In this one, just forgive me, I'm gonna skip that analysis. But take a look at the playlist of this video, and you'll see 20 prior examples of where I go into much detail. So what we're going to do is we're going to set this value equal to 0. So we've got x squared being equal to 0. All right. Then we're going to take the 2x plus 3 raised to the fifth equal to 0. Now, you'll see one thing that we can kind of skip over, but I'm going to include it right now. So what I'm doing is I am including those powers. All right, but we probably don't need them. I'll explain why in a second. So let's just solve this for x now. Right, I would have to take the square root of both sides. The square root of x squared is just going to be x. Square root of 0 obviously is just 0. Remember, the square root, you're saying what times itself 2 times gives you 0, and obviously the only answer to that is 0. Now, in this case, I have to get rid of the fifth power. So in order to do that, I raise that whole side to the 1/5 power. And the reason why this gets rid of it is because when you take an exponent and you raise it to an exponent, you're basically multiplying those exponents together, and 5 times 1/5 is just 1. You got rid of the 5 now, okay? But remember, mathematically, whatever you do to the left-hand side, you better also do to that right-hand side. So in other words, you got to raise the 0 to the 1/5 power. So what's going to happen is this is then 2x plus 3 equaling now 0. This is asking, or this is, the question you're asking yourself is what times itself 5 times now will give you 0, and obviously it's still 0. So minus the 3 on both sides, okay? Minus the 3 onto both sides. I don't know what kind of a number that is, but there you go. So that's going to be 2x is equal to negative 3. Divide this by 2 on both sides, and x will be equal to negative 3 over 2, or about 1.5, okay? And last but not least, we're going to do the same thing. Take the square root of both sides over here. And remember, that's going to get rid of the square, so that's x minus 4. Square root of 0 is obviously 0 for the same reasons as we discussed over there. Add the 4 to both sides, and now, lo and behold, you have your zeros. In other words, these are the x values where the function's value should touch the x or cross the x-axis, okay? Where the function's value is therefore 0. Where the y value will be 0, in other words, okay? So now what I'm going to do, let's just move this on over to the side. All right, so those are the values. And why don't we just get, I'm going to erase this. Why don't we just get an idea about what the function should look like? And we'll use the calculator, okay? So go to your calculator, go to y equals, all right? Plug in x squared now, x squared. Open parentheses, then this is going to be 2x plus 3 raised to the fifth. Hit the over arrow, bring it down, open the parentheses again, then it's going to be x minus 4. X minus 4, where's the 4? There it is. And square it, okay? Now hit graph. Okay, so your window might be a little different than this. Go to zoom, go to standard, because this is probably what you're going to see. And, right. So we have something that, we have a problem. Houston, we have a problem. Okay, we have a problem. I want to show you something here. This is very infrequently does this happen, but this can be very frustrating. So watch. Let's change your window. Go to x is equal to negative. Why don't we do 2? Let's go to negative 2, and let's go all the way out to then x is equal to 5, and just hit graph again. So watch. If I take this on in, okay, if I bring it on over. Now, a couple of things are happening here. We said that the function should touch or cross the x-axis in 3 spots. Does it look like it is? No. Now immediately, what do we say? Oh, I must be wrong. There's no way the calculator's wrong. Right? But you go back and you check your logic. You think about how to find those zeros, okay? And you make sure that you're right. Now, if you're convinced that you're right, stick to your guns. Okay? The calculator's wrong. You might say, what? How can the calculator be wrong, Andrew? I mean, come on, give me a break. You have to remember that this calculator is pixelated. Okay, you see how this is not a smooth curve at all? So what happens sometimes, if values are very sharp, or if values are very, what's the word? If there's not a lot of variability in some of the values, you miss a lot of detail with these calculators. In other words, this doesn't even look like it's going to touch the x-axis, but guess what? It will. It does. Okay? It's just that there's not a pixel there for it, basically, to be shown. Now, that's very frustrating, right? So you're like, okay, well, what are we going to do? Right? Now, just remember, but that skill, just in general, just to kind of give, right, a little life lesson here, that skill is very important, okay? If you think you're right and you know your method is sound, stick to your guns, all right? Don't assume that you have to be wrong. You go back and you check your logic, okay? And if you're right and if you're convinced, I don't care if the calculator doesn't agree with you or somebody else doesn't agree with you, you're still right. But you got to make sure you are right. Go back and double check. Now, so the calculator is wrong, basically. So how do we see this? So what I'm going to do is I'm going to graph it in a different function, or not in a different function, but I'm going to graph it using a different program, and I'm going to plug it in now. Bam. So here's the output, and you can use this online. It's a graphing calculator online. It's called Desmos. It's great. Okay, so now what do we have? So now let's locate the points. Now this -2, by the way, is talking about, the point on over here, okay, at the edge. So that's -2. This would be -1. So if you notice, this is crossing right in the middle, or -1/2. Oh, -3/2, right? So that sounds good to me, so that's cool. Notice how the graph is touching then at 0. Okay, that's what we said it should do. And lo and behold, look at this. Looky here at 4, right? You see where it touches the x-axis? Okay, so this is, like I said, the calculator. I plugged in the same thing, but we're looking at 2 different graphs almost. Okay, you just got to be careful. You got to understand the limitations of the tools you're using, right? That's very, very important. If you don't understand the limitations of the tools you might be using, then you might not realize when you might be right and the other thing might be wrong. Okay, so keep that in mind. Keep that in mind. Now, what we can do from here is we can now give, and I don't need the graph to kind of give the multiplicities, but I just want to kind of give you a visual on this. The multiplicities are basically, you can kind of memorize this if you want, but there is a pattern I definitely want you to understand. And take a look in the link in the description below, or at the link in the description below. I'll leave you a video about how I explain why odd multiplicity gives you such behavior and even multiplicity gives you such behavior. I think it'll be very helpful. Anyway, when they ask you for multiplicity, they're just asking for the power of the 0, basically. Okay, so in other words, we found that x is equal to 0 by looking at this factor, right? By looking at this particular factor. Now, what's the exponent of this? It was a 2, okay? So what I can say is that the 0 at x is equal to at x is equal to 0 had a multiplicity, I'm just going to write mult, equal to 2. That was the power, okay? Then when I solve for the other 0 for x, basically, right, it was equal to -3/2. The multiplicity of that was 5, right? That was the power. We solved this to get the -3/2, and the power of that factor was 5, and therefore the multiplicity was equal to 5. And last but not least, for the 0 value of +4 for x, which we got by looking at that factor, the power of it was 2, and therefore the multiplicity will be equal to 2. Now, it turns out that the odd multiplicity, why do I keep doing that? That's an even number, Andrew. That's an even number. The even multiplicities, okay, and the odd multiplicities give you different behavior. Odds always cross. Evens, let me put in a different color, evens will always bounce. Or you can think just touch. Doesn't matter. Bounce. Okay, so notice there's one odd multiplicity happening at -1/2, and you see how this actually will cross. It starts negative and it ends positive, basically, so it crosses the x-axis. And if you notice these other values had even multiplicities, you see that they bounce off the x-axis. It's like they come down and go boop, bounce off, and they come down and they go boop. Okay, you gotta like the sound effects. You gotta like the sound effects. In any case, they're always going to just bounce, go boop, okay, off the x-axis. So if you have an even multiplicity, you're going to think in your mind, boop, okay, boop, boop. I don't know why that kind of sounds like a, I feel like there's an EKG in the room, okay, boop, 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 boop. Wow, I'm getting distracted. Okay, anyway, So if you want to, though, know why those multiplicities have that behavior, please check out the link in the description below. I highly suggest you do it. All right, I don't want you to memorize stuff. I want you to understand stuff. That's the whole point of our channel. Okay, that's why we have thousands of practice problems out there. Literally thousands. Not only the math here, but physics and chemistry as well. And we take a very detailed approach to teach you how to do it and why it's happening. Okay, so if you really want to understand what's going on, please utilize our channel. Okay, and if you don't, no problem. We wish you all the best anyway. We'll see you soon. Take care.